Okey.
Okay, salam sejahtera kepada Dr. Azazi. Kami dari kumpulan 3 dan kami punya tajuk adalah Non-Destructive Testing iaitu NDT untuk Guided Wave Testing. Saya Kelvin Prasapana Ujan, nombor metrik B0919103224. Okay, next slide. Okay, so I will read the fundamental of non-destructive test for guided wave testing. Guided wave testing is another term for long-range ultrasonic testing and is a method for rapid screening of pipework for corrosion and erosion. A description of long-range ultrasonic testing, but it is highlighted as the GWT, which is the guided wave testing, because this is the term used in the new range of standards that have been used. The standards give the definition of guided wave as sonic or ultrasonic waves that travels along an object that are guided by its surfaces or shape. The wavelength is large compared to a characteristic dimension such as wall thickness. Guided wave testing is testing of a large volume of material from a test location, utilizing the long distance propagation characteristics of guided wave. Okay, next. Next slide. Okay, these are the fundamental of guided wave testing. There are different kinds of guided wave in a pipe. These modes can involve circumferential motion as well as axial motion. The different orders of mode related to the extent of the circumferential motion, with zero order having no circumferential motion. First order having one cycle of sine wave around the circumference. There are three families of modes. The first one is torsional, which have only displacement in the circumferential direction. These have zero order modes. The second one is longitudinal, which have displacement in the axial and radial direction only, and so are also zero order modes. These displacements are referred to as extensional and breathing motions. The last one, flexural modes, which have displacement in all directions, giving a bending motion. These flexural modes cover all the other higher order modes. Okay, next. Okay, these are the example pictures of how the guided wave testing being performed. Generally, the attenuation characteristic of ultrasonic guided wave testing compared with shear and compression wave modes used for conventional ultrasonic testing that are inherently low. This test range with guided wave technology in ideal condition are around 50 meters in each direction for a bar pipe. So this is how the guided wave testing are being performed. Okay. Okay, that's all for me. I pass to the next presenter.
Okay, thank you, Kelvin. My name is Mugilarsan Subramaniam. So my part is about procedure. These are the step of procedure: inspection equipment, monitoring equipment, wave pro software, transducer rings, monitoring sensor, and GVT transistor, and out to GVT transistor, and accessories is cables, adapter modules. For the information on another inspection alternative, the sensor is read using 3D laser analysis for non-destructive testing and evaluation of pipeline correction. For the result is screening process are the inspected in more detail using conventional non-destructive testing method. After that, a comparison of waves with waves is illustrated in figure above. Note that bulk waves cover only a small localized section of the structure. After that, scanning is necessary to complete an inspection of the test part. The ultrasonic guide wave float are large area from a single probe position, and two basic guide wave excitation examples include, include angle beam excitation and comb excitation and illustrate like figure above. Furthermore, GWT is composed of ring of zeoelectronic and magnetronic transistors that are coupled around the entire circumference of the pipeline. Then these transistors generally receive low-frequency ultrasonic waves that are capable of traveling through the pipeline valve. The frequency wave usually is 50 Hz range, which is much less than the 5 Hz range used in conventional ultrasonic inspection. Okay. The next part is about advantage. The big advantage of guide wave testing is that the ultrasonic guide wave travels along the axial length of pipeline with low attenuation. Other NDT testing such as ultrasonic, RT and ET is a spot measurement tool with which the test area is limited to the probe installation location. Second is long length of pipeline can be inspected, giving comprehensive condition information in a short time. The third advantage is inaccessible location can be inspected, like soil air interface, concrete air interface. For example, if the concrete is not bonded to the pipe, wall penetration, fluid pipeline, and road correction pipeline. The fourth advantage is long length of pipeline can be screened with several access locations for installing the guide wave probe and for flow-up testing in indication is found. Significantly, it's reduced preparation time and labor, scaffold of high evaluations pipeline and removing installation of insulted pipeline and also excavating buried pipeline. The last is high temperature pipeline. It's up to 500 degrees Celsius. These pipelines can be inspected or monitored during the normal operating without removing heat tracer lines. The next is disadvantage. First point is interpretation of data, highly operator dependent. The next is difficult to find small pitting defects in pipe. Third is not very effective at inspection areas close to accessories. And next is can't find the gradual wall loss. And last is needs good procedure. That's all from me.
Assalamualaikum, nama Shukri bin Ahmad, and I'm going to present about the improvement of latest technology. Firstly is through technique development. Commercial guided wave system for pipe operate by transmitting an axisymmetric wave mode, either T01 or L02, along the pipe at a frequency which gives a frequency multiplied by thickness product less than 1 millimeter. While it's accepted that viscoelastic coatings attenuate guided wave at a greater rate than this, there is hardly any useful quantitative data available for the actual attenuation rate caused by such coatings. Next. So for the experiment, we have done a teletest guided wave unit, which is used to generate and receive signal. This method allowed the predicted attenuation rates for the two modes in the denso coated pipe to be compared with measured values. The results are shown in figure below. This indicates good agreement between the predicted and measured values, which suggests the modeling method is a good means of predicting the influence of coating on the practical test performance. Next. The second improvement is through procedure enhancement. For practical testing of pipes with highly attenuating coatings, there are two main considerations. First, the rate of attenuation gives rise to a very wide range of amplitude in the received signals along the test length, which is potentially many meters. Second factor that affects the result from guided wave tests on coated pipe is the level of scattering observed on the trace. This reduces the signals to noise ratio and hence reduces the sensitivity to defects. Next. So by adding delay before the start of data collection, the high amplitude wells in the uncoated part of the pipe can be removed from the data, and much higher sensitivity may be used without the signals becoming clipped and distorted. So in figure 4, we can see the left side, which is a test run with no delay applied, and the right side is a test run with a 16-minute delay before data collection commences. Secondly is by moving the transducer close to start of coating to improve the amplitude, visibility, and reduce noise. As we can see on the left side of the graph, we can see full length trace may be compared with figure 4A, and on the right side, zoom plot of the weld tree region. Next. This is the related project done by industries, which is Iris NDT, a company from Germany which is specialized in NDT. So the first picture we can see a guided wave testing on internal corrosion. So the job detail is involving a 6 inches crude oil line and non-painted surface on a desert terrain with no pipe supports. So the wave maker utilized wave modes that energize the entire volume of the pipe. Therefore, it is ideal for detection of internal corrosion. And on the right side is a guided wave testing on defects in elbows. So details is the job details is involve a 16 inches crude oil line and type 1D elbows. So bend or elbows are common pipe fittings which are susceptible to corrosion and erosion. Using guided wave testing, especially the C-scan, we can detect defect at elbow and be prioritized. So that's all from me. I will pass to the next presenter. Thank you.
Okay, thank you, Shukri. Assalamualaikum and hi. My name is Zulhari Abdulaziz. Next, I will proceed with the conclusion. To sum up, in one of the more recent applications introduced into the NDT Practitioners Toolkit, which is Guided Wave Testing, GWT, has generated much interest over the past few years due to the level of coverage. It affords to pipeline operators and the relative ease with which it can be applied. When applied to the screening of pipelines, it provides 100% volumetric coverage of an extended axial length of piping in a relatively short period of time. When properly applied, it has proven to be of a great of use to pipeline operators wishing to establish the integrity of highly inaccessible sections of their lines. When using GWT, all parties involved should be mindful that it is a screening tool sensitive to changes in cross-section area and pipe stiffness. Pipe, stiff, pipe stiffness. Although most GWT systems are able to provide the user with estimated wall loss values for indications that have been detected, the need for accurate remaining wall values requires the use of a secondary method, typically conventional UT, to measure the actual remaining wall value at the indication. Therefore, guided wave testing (GWT) has proven to be an effective means of performing rapid condition assessments on extended length of piping and shows a great promise in monitoring applications. Its rapid success has led to a general consensus calling for development of an independent, industry-driven training and certification program to guarantee a minimum level of competency for field technicians. Okay, that's all from us. Thank you.